Well, welcome to our structural modeling video conference. It's the additional week 3 video conference, which is we're going to have Kevin Dye kick off today with some comments about temporal logic. So, Kevin, yours.
Okay, so I'm going to take the screen over.
Yep.
Can you see that diagram?
It's there.
Okay. So I was doing a lot of IDEF modeling, and we were doing a very large model, which was from concept to testing, concept to manufacturing to testing of a jet engine. And there's like six or 7,000 functions in that map. And that's why I was interested in interpretive structural modeling, so we could do a more robust consideration of potential interconnections between the functions than was typically done. The way IDEF 0 modeling was typically done back in the late 1980s anyway, is you had a couple experts that were expert in the model, expert in the existing model. Then they would look at a new process that they wanted to model, and they would base it on another model and make minor modifications to it. And they didn't actually go through and robustly consider all the possible interconnections the way you might do in quality function deployment, or the so-called house of quality. So IDEF 0 modeling in practice was not following a total quality management regime and how it was performed. And so that's what I had hoped to resolve with interpretive structural modeling. And then when I looked at modeling something like a function, there wasn't a lot of documentation from Warfield or Christakis about doing that. I think they had a model of a fuel pump or something like that was modeled in terms of functions, so-called engineering model, or that's how they called it. They didn't say too much about it, except, a function of something else follows a transitive behavior. A function, by definition, is transitive. That's a little different than IDEF. In IDEF, a function has inputs and outputs, but it also has mechanisms and controls. And so you need more than just a mathematical function to model IDEF. But let's just focus on modeling something that's a function of something else. The thing that there is a lot written about in ISM is modeling influence relationships. That's the most common type of thing to model with interpretive structural modeling is influence. And if A influences B and B influences C, then it's generally inferred that A influences C. So it's influence is transitive, and but it's not signed. So if A influences B in a positive way, and B influences C in a positive way, then you infer that A influences C in a positive way. But influence might go the other way as well. Generally, people tend to ignore that. But an example, a more restricted influence relationship that is signed is aggravates. So, and this is the relationship that John Warfield spent most of his career modeling in the so-called problematique. So in a problematique, the nodes are problems and the relationship is aggravates. So does one problem aggravate another? So aggravate is if something aggravates another, we don't think of it as of something aggravating negatively. In other words, having a positive effect on. It's pretty reliably interpreted that aggravates means it makes something worse, whereas influence can make something worse or better. So so there's some relationship, I thought, between something being a function of something else and something influencing something else. So I thought that we could apply similar logic as the influence relationship. As I started getting into it, I found that its influence is more ambiguous. It's a more ambiguous type of causality than a function. And I found another type of thing that Warfield modeled early on, before he created interpretive structural modeling. He was trying to come up with a new graphic language that he had a couple different names for. One of the names was Grail, and it was basically a PERT diagrams with and or logic built in. So instead of just one process linked to another process or two, you could have a split where the one process could take either or another one of two paths. So he had an OR gate in the PERT diagrams, and you also could combine. So if two processes were required as input to a third process, then you could he would use an AND gate. So this is probably because he was an electrical engineer and he liked AND and OR gates. But he also had a penchant for he wanted to create his own language, his own graphic language. This is before interpretive structural modeling. Anyway, in that language he had, when he said one thing preceded another thing, he treated the things as nodes, as points, without a start or an end. They were just, if something happened before something else, that was it. It didn't say anything about whether those processes started and stopped before another process started and stopped, or if it overlapped or anything like that. So that's what led me to the diagram that you're looking at here. I was doing work at MIT on something called the Process Handbook Project, and there they were modeling processes and dependencies between processes. And one of the dependencies is one aspect of a dependency relationship is the temporal aspect. And to model the temporal relationship of processes, you have to model the relationship of intervals. And Thomas Allen, who I think is in, he's in New York somewhere, Cornell or State University of New York, I'm not sure. He developed what's sometimes called interval logic. It's also called or interval algebra. It's also called temporal logic. And he claims that as we mentioned last time, that goes back to work in the Arab world, that this type of thinking had been worked out. So I thought that, well, this is good. We have a lot better clarity when you say something precedes something else, what it means, because you can be specific. There's a much richer vocabulary than just precedes here. So in Warfield's world, if you said A precedes B, it would include the first one, the second one, the third one, the fourth one. And I'm not sure about the sixth one. And so it's Warfield's approach to doing modeling his PERT diagrams, and also in modeling influence relationships, is kind of undefined at the level of considering something that actually takes place in time. So to me, if you're modeling influence, you could consider it a type of causality. And if there's a causal relationship between two things, the two things generally take a certain amount of time. There's hardly anything, except maybe at the quantum level, that happens in zero time. So most anything we want to model there's going to be between something that takes a certain amount of time and a second thing that takes a certain amount of time. And so worrying about the relationships of the beginning and end points of those two things, I think is useful. The question is, how do you ask this in interpretive structural modeling, right? If you just consider, if you forget about time and you just ask about the relationship of 2 points, does one precede another? Then you only have to ask one question. But if you ask about the relationship of all the beginning and end points between two processes, you have to ask 13 questions. Or you have to ask people, if you say, what is the relationship between A and B, people have to be able to respond with 13 different answers. So they'd have to have this list, for example, in front of them, and you'd say, how does A relate to B? And then put it in, people would make their statements. Then they'd have to have a discussion about them. So suppose one person says A precedes B, and the other person says A overlaps B. How do you have a discussion about that if people are not facile with all of the terms? So I was reading a paper by Russell Ackoff in the Operations Research Journal, and I think he did it in the late 50s. And he was talking about the relationships that he called production functions. And this gave me some clarity. And what he was saying was the relationship between two functions in terms of a production function, like in manufacturing, there's something produced by A that B needs in order to produce what B is going to produce. And this gives you some clarity on which relationship to focus on. Because in terms of a production function, all that you care about is that A produces its thing so that B can produce its thing. Right? So this simplifies what relationships you're interested in. You're interested in just the relationships of the two end events of A and B, not the whole interval. So you can ask, does the end event of A precede the end event of B? And that is enough. And that actually covers all the other relationships. All the other relationships are a refinement of that basic relationship that the end event of A preceding end event of B. So I found this simplified doing an ISM for, or how to think of an influence relationship too, although this is not written by Warfield or Christakis anywhere, that if something influences something else, first of all, there's a more basic relationship, which is something happens before something else, unless you have reverse causality, which is, people have theories about it, like time travel, but for most of the world that we want to model, we're not looking at reverse causality. If you're interested in the influence relationship, then a more fundamental relationship is a temporal relationship, and of all of the combinations of intervals, like you see here, the one that we're most interested in is just the relationship of the end event of one and the end event of another. So I think that's, I'll save for now, and we can have a discussion.
Well, let's see. That's interesting. I mean, from a number of aspects, from my point of view, anyway, because the just been working on relations and relation categories and relationships, right? Natural language relationships. I call these natural language relationships. They're not mathematical relations. Kind of try to make that distinction, because there's and I think it's an important distinction, because if we look at those, what do you got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 natural language relationships, and those are really important in defining a system. But for a mathematical relation, you would also have a 14th one out here. It's called null. The name of it would be null. The A and the B would be null, and it would have a null zero type of assignment to it, which would make sense mathematically, but really wouldn't make sense in natural language. So I try to make a distinction between a mathematical relation and a natural language relationship.
Janet,
I saw something. Oh, okay, go ahead.
Janet has written a question. Is there an issue when some nodes in a model may be clearly temporal and others not? And maybe your point is addressing this.
No, what I'm trying to say, I think, is a little more fundamental. I'm trying to make a distinction between the word relation and reserve that word relation for a mathematical relation, and use the word relationship for a natural language relationship. And let's see if I go back here to Kevin's presentation, and then you can see the chart. Ah, there it is. There's the chart. So that this name tags at the top, right? Precedes, meets, overlaps. Those are all natural language relationships. And they have a vector of 13 natural language relationships. But from a mathematical standpoint, the set there's always the null element in the set. And so if we had one that said the name of it was null, A and B were empty, and it had 0, let's say, or some other symbol for a name tag, that would make no sense in a natural language relationship. But it would make sense in a mathematical relation. And so there's a couple of places where these things appear to become confused in the literature if you don't start making a clear distinction between a mathematical relation and a natural language relationship. That's just trying to define these things here. Table 1, I would call natural language relationships. I would not call them relations because I reserve the word relations for mathematical relations. Does that make sense?
Yeah, I think it depends on how Alan uses them. You know, if his interval algebras using these words to describe the relationships. But I understand your point. It's not
okay.
But anyway, what were you
well, I think
responding
we need
to?
that level of definition. We have that level of definition that basically then that will help us eliminate uncertainty about what we're talking about.
Oh.
But we could map those, you know. You say, okay, because a natural language relationship can be represented directly as a mathematical relation. I mean, they're not mutually exclusive. There's just some corner cases that create problems.
I was going to come back to Janet's question. Is there an issue when some nodes in a model may be clearly temporal and others not? I mean, there's an issue of whether you're doing modeling with ISM at all, because a basic presumption of ISM is that all nodes are of the same type, and you're dealing with a single type of relationship amongst the nodes. And no one tries to use ISM with multiple types of relationships or multiple types of nodes. That doesn't mean that you can't do it. It's just a basic assumption of doing ISM is that you're dealing with all nodes of the same type and all relations of the same type. So when you're asked, is there an issue when some nodes may be temporal and others not? Yeah, there's a major issue. You may not be modeling what you think you're modeling, and it's one of the I would guess trade-off. I don't know if I'd say weakness, but a trade-off of using ISM is as compared to something like concept mapping or CMAP, where CMAP you're modeling a rich set of relationships amongst a set of items, with a bunch of different relationships that are semantically rich. And I would say, in comparison, ISM is semantically spare. It's not modeling something rich semantically. And
yeah, I think there's a trade-off there, Kevin, and it's interesting. Those are two very interesting elements and ways to represent concepts and semantics about systems. But if you look at the structural modeling natural language relationship approach, where your ISM, you build a single relationship and then you build the structure of the system, then it's semantically spare from, ISM is semantically spare from the standpoint of the prose, the verbal, this word, this relationship that we're looking for. However, because you have restricted the prose or the words to one natural language relationship, that gives you, I believe anyway, more richness in the definition when you're looking at the mathematical and the structural graphic definitions and the semantics that you can associate with the graphic configurations and the mathematical configuration. So I think there's a trade-off in the languages there. So that if you restrict that, prose point of view properly, then I think you're able to gain some more semantics in the structured graphics and in the mathematics realm. And if you mix everything semantically in the prose, in the concept graphs, I think you lose some of that richness in the structured graphics and the mathematics.
Another way to answer Janet, like suppose we have an example that is what she's talking about. Like we're modeling, so let's suppose we're modeling a manufacturing process for a car tire. And so we have a bunch of the sub-processes. And we're also interested in which of the processes most pertain to quality. So as one of the nodes, we don't have a process, we have attains high quality as an objective. So the objective is not a temporal, it's not a temporal node, it's not a process. And so there's two questions that come up. One, if you're trying to include it in a single ISM model, does it make sense to ask about an influence relationship between something that's temporal and something that's not, like an objective? I think, influence, if you'd say, does doing process A and B well produce high quality as an objective, I think that makes sense. So influence would seem to work, but the underlying idea of temporal doesn't map to high quality objective, because high quality objective doesn't have an interval. But you could reword the high quality objective and say, measure high quality, and turn it into a process. You don't know if something's high quality until you measure it. So you can just say.
Yeah, that's an important point, I think, Kevin. But also, I think the idea of ISM and being included in the science of generic design, on one hand, depending upon the type of ISM activity that you're doing, whether you're doing, say, a problemmatique, you're trying to find the structure of the problems, or you're doing an enhancement structure, or you're doing, objective structure, these different structures. If you're using the ISM structural modeling as an input into a generic design process, then the fact that whether or not the nodes are temporal or not is part of the design. You would actually say, well, I have to do this before I do that. Or, this has to exist before this is a problem. So those types of things where you have cycles, or naturally occurring cycles, or things that feed in and create certain types of problematic situations, that would be detected by the ISM structuring the problem set. And then I assume as part of the design process, you would design an intervention for that, or enhancement that eliminated those problems. And that's where you would take a lot of this temporal information into account. So you probably need to know that it's temporal and it has some type of cyclical impact, but that wouldn't be as important in discovering the problems, I think, as in when you're designing the enhancement or the intervention.
Oh. Janet had a follow-on, which was, so she said, so ISM picks up from the point when facilitator can ensure participants are disciplined to have one type of node in relationship. And that's actually a point of controversy in the facilitation circles. If you're doing engineering modeling, and then I think it's really important to make sure that that there's a filter after you pose a triggering question and ask people to name, let's say, all the processes that they're trying to model. There should be a filter where, you know, the facilitator, where the facilitator asks the group to ascertain whether everything is indeed a process in the list, or if it's a sub, you know, does it include other things besides processes, and the things that are not processes, can they be restated as processes, or are they something else for a more complex model that will combine an ISM model with another model? Because we in Warfield's work on interconnection matrices, we're modeling multiple relationships between, for example, solutions and problems. And we'll have an ISM of solutions and an ISM of problems and a cross-impact matrix or diagram of how the solutions map to the problems. So it's not that we don't model multiple relationships or multiple types of nodes, it's that we segregate them. And there's a famous paper about why you might want to do this. I think the name is Dijkstra, and his paper's called Separation of Concerns. Have you heard of that one?
Yes, yeah,
it might not be a formal journal article. I think it might have been I'm just calling up the name here.
It's standard computer science.
It was a paper about how you do encapsulation and modularity.
Yep.
But it was very early and influential on software engineering. Yeah, Dijkstra, Dijkstra, and it's in a paper, 1974 paper called "On the Role of Scientific Thought."
Yep.
The idea of separation is concerns is you look at one aspect at a time. I don't remember Warfield ever citing him, but that's the type of thinking that was going on. And it's an engineering mindset. It's not a semantically rich linguistic mindset. You know, but to come back to Janet's question, her point about making sure that the participants are disciplined. So in the as I said, in the engineering context, we want a high degree of discipline, but that requires policing the language of the participants. And if you're modeling something in the social world, in which where it's important to preserve the autonomy of the individuals and the diversity of the setting and inclusiveness, then you want to be very careful to not step on the wording of participants, because and this is a classic behavior of facilitators. You'll hear often a facilitator at a flip chart working with a group. They'll say, okay, what is your idea? And then when the facilitator goes to write their idea, they'll write, like, instead of the whole sentence of the idea, they'll start writing a couple words of the idea, and they'll say, what I hear you saying is, but if they say that, you know they're not right, they're not saying what you said.
Yeah.
And in a social justice setting, for example, in the work with Native Americans, you reword something that they said, they're not that appreciative of an, you know, especially if it's a Caucasian facilitator with a Native American group and you're rewording their language. I mean, this is really politically charged when you do this. So if you're, you know, so the context is really important about the facilitation. If you're within a company where you expect to be disciplined, where you expect to have filters, where you don't mind, you know, where it's not a social justice issue, which, you know, you're talking about something more objective, the relationship of parts in an engine, and it's not about actions or problems I'm having with poverty and why the school system's bad, and that there's social injustice and racism. So, you know, if depending on the context, you can police the language better, and as a result, the types of things you model in a social engagement is different. You don't try to model the functions of a car engine or the processes of manufacturing in a precise way in a social thing like reinventing democracy, right? If you ask people what are the challenges you face with democracy in your country, people start pouring their heart out about watching their cousin get killed by the police. You do not want to say, "Oh, I'm sorry, you didn't state that in the form of a challenge."
Yeah.
You know what I'm saying?
Yeah. 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 Well,
it's a little fuzzier.
There's an interesting, a very interesting aspect, I think, that's happening, and it's kind of goes back to some of the things that we were talking about earlier, and that's about the number of people that are specializing and interested in systems. And so, just in general background, we look at like algorithms. Like Sedgwick has been teaching algorithms for a long period of time. And it used to be when he started back in the 60s and 70s, very few people studied algorithms. But now, almost like over 50% of incoming freshmen into universities study algorithms. It's just something you have to know, right? And it's kind of a structured type of language and approach. And so that mechanical type of processing and so forth, the language and concepts, is starting to permeate certain sectors of our society. And if you take a machine type of communication system like computers, machines have to understand things semantically using, semantically, it's based on syntax and rules and logical rules. That's basically how they have to work. And we look at the logic and so forth that's associated with ISM and a number of these other processes. There's a mix between natural language, human type of semantics, and also the more structured type of logic. Humans communicate based on context. Humans have to have a shared context. So if you are a Native American, you have shared context with Native Americans. You don't have shared context with the people that live in Manhattan and on Wall Street. Two completely different value sets, two completely different sets of experience. I would expect that the ability for those people to communicate is almost zero because they have almost zero shared context, right? So, and that I think is an important distinction, and it's a barrier. because I see in my experience with large organizations, one of the things that they tend to do with people is they try to like hone down the syntax, like with UML and IDEF and stuff like that. They try to make things more and more and more syntactically precise, without giving any resources or effort to building a common context within which the humans need to understand the semantics. And so that I think is a really important point. And in many cases, it's not even recognized or addressed. In fact, how would you address a situation like that, Kevin?
How address a situation like what? What do you mean?
Well, what you said, you have a Native American, right?
Yeah.
And a facilitator says, well, here is what I hear you saying. And because the facilitator and the Native American don't have shared context,
right.
So
right.
Yeah,
I think even when there is a shared context, saying instead of saying exactly what someone says, saying here's what I say you're saying is an imposition. Why do you have to restate it? And the difference in context makes it even worse. But that was the whole point of concurrent engineering when it first came out in the 80s, was that the people in design never sat in a room with people in manufacturing and shared across contexts. And it was techniques that came out like quality function deployment to promote the crossing of context was so important. It was it was people listening to the concern, a designer listening to the concerns of someone in manufacturing was more important than filling in the quality function deployment matrix. And that was the real value of it,
Yeah, that is interesting. I know that there was an example of a very large aerospace company that went to all digital product design and to feed the digital machines that did the manufacturing.
Yeah.
And they sent out a rule to the engineering that, engineering groups, manufacturing groups, people can't talk to each other unless there's a conflict in the digital system, right? So it took the engineers about a week or so to figure out, okay, if I want to talk to Pete over in manufacturing, I have to make sure that I have a conflict here. They start putting in intentional conflict so they can go talk to Pete. So yeah, it's totally very interesting approach when you try to do that, but it just shows the importance of shared context. People have to talk to each other.
Yeah, it's a big problem in the military. The work I was doing in the Air Force the last few years, they're very big on what they call their swim lanes.
Oh yeah.
And you don't want too many touch points between the swim lanes.
Yep.
And yet the leadership at the top is saying we need more interdisciplinarity, we need more integration. But the middle management is making sure people don't talk to each other or they're considered outside their swim lane. But I think that in the way that interpretive structural modeling has been practiced, it's been used to deliberately serve as touch points between swim lanes. I mean, there are examples where it's used within a swim lane, but I think more often it's coupled with an attempt at interdisciplinarity.
Yeah, there's
and partly the reason that I think it gets used like that is you don't do an ISM session on something more than once, like every 5 years. Because it's very costly. You need, like the one we just did, had 20 people in it for 5 days. So that's 100-person days plus a 5-person facilitation team.
Yep.
And working before and after the event for months. It's an expensive endeavor, just in terms of people's time. And the cost of the facilitation is about 1/3 of the cost compared to that. And it's intentionally disruptive.
Yeah. It's interesting. I think what I've seen from looking at highly organized, compartmentalized systems like the military is that there's a couple of contextual problems. And one of them is when you try to go and say, well, here's our problems, and you get the problem set from inside each swim lane, but the solution, but that restricts the value of ISM because you don't see the whole problem, because people can't talk to each other and they don't know the whole problem. And same thing is when you do the enhancement. Say, okay, I'm going to create some solutions. Well, they're creating solutions for within their swim lane or their area of responsibility, AOR, but they are not looking at anything else because that's really not their area of responsibility. So what tends to happen is intervening concepts like logistics, safety, those types of things that go across them all, right? Verification, validation, continuity, mission readiness. Each one of those, when they go in and they start dealing with large groups, what happens is you get every one of those specific integrated, quote unquote, activities or supporting activities. You get every one of those in terms of each swim lane. And so each swim lane actually, so if you were supposed to have like one requirement on supportability, right, for your whole system, you might get, 10 or 15 or 50 different requirements, 1, 2, or 3 from each different swim lane that's modeled right to what their area of concern is. But you're not doing that just for the area of concern, you're doing it for the whole system. And that becomes that is a real problem. And what happens is then it goes against the idea of, you're supposed to have more and more requirements. When you collect them that way, actually what you have to do is weed out a whole bunch of requirements and integrate them and say, this is the same as that, right? And that's what they don't do. Like what you've seen in ISM, where you ask a question, you allow people to say, my concern is the same as that one, so I'll withdraw my concern, right? So you get a lot of these requirements are all generated up. They never go for that step. They never go and say, review these and see if they're the same, right? I've never seen that done.
Yeah. One thing we do when during the nominal group techniques phase, we'll ask people, it's part of asking clarifying questions, to ask an author to point out the relationship of two things which seem similar to them, and ask the author to distinguish them. And if they can't distinguish them, they might recognize them as being similar, but then the two authors have to agree that they're the same thing. And usually there's a drop off of about 10 to 15% of the ideas that are judged to be similar. But I've seen cases where things are stated with the same words, two ideas stated with the same words, and after a discussion, there's to determine that the authors mean something different by them.
Yeah.
Janet's indicated, getting back to the discipline relationship distinction, it seems Allen's algebra is proposed to distinguish both mathematical relations and natural language relationships. If you bring that chart back up again, Kevin, I noticed the same thing, or seemed to.
Can you see it?
I can. One of the distinctly mathematical relations, of course, is equals. Another is precede, I would guess. But both of those can also apply to the natural language relationships. And so part of what this chart has done is made me aware of how important it is to determine the context that he was coming from. In other words, his 13 basic relations, and it's within something called an interval algebra. Is that right?
Yeah.
Is he representing, in fact, a mathematical perspective here as opposed to a natural language?
Yeah, he's focused on the development of planning systems. So he's not that concerned with language so much.
So I think that this what we're seeing here shows the benefit of the abstract relation type and the isomorphism, because we require that it means the same in prose, right? And in structured graphics and in mathematics. So for the next technical report, we're working through the table that Warfield presented. I'll put these in if there's any others, if some are in here that are not in Warfield's, and have a discussion about those. And so the idea is, of course, is that in this case, you want them to be isomorphic. You want them to have a prose representation that's isomorphic to a structured graphics representation that's isomorphic to a mathematical representation, all three equal. But if you put, as I said, the idea of a mathematical relation, if you're looking here at this set of relationships, there's always the idea of the null set, right? Yeah. Which would make no sense. And so there's some just these corner cases that need to be discussed, because in Warfield's chart of relationships, he put the natural language relationship as not related to. And so, okay, well, that's the null relation, right?
Yeah.
And so those are the things where, as Mary pointed out when we discussed talking about this, that makes sense in natural language, right? But it doesn't make sense in terms of a system, because you have to have a relationship between the objects. And so if you say there is no relationship, then there is no system. So it's just those types of things that the art brings clarity to. And we can, by using all three forms of language, we can express them in the same thing in different ways.
Just as a note, I mean, Allen's work was on artificial intelligence approaches to planning. The thing, in order to do inference on interval relationships, you need to know what's transitive. So you need not just not the relationship of two things, but at least three things to define transitive relationships.
Yep.
So we have 13 relationships between two processes. There's a large number of relationships between three processes, and then whether the relationship is transitive or not. What does it mean to be transitive?
Yeah, so that's...
And then one further step is what he calls modal temporal logic, which is if A precedes B, never, sometimes, or always. So if you have a three-value instead of yes or no.
Yep.
And then how does that propagate transitivity? And so just as extending this into modal logic, then what I found was if you ask, does A at least sometimes have to end in order for B to end?
Mm-hmm.
That gives you the most transitivity across intervals. It's the question with the smallest way to say yes or no for the most that covers is a baseline for all the other combinations of relationships.
That's really a good example, and I think if you can send out or email me these references, then I'll email them out to the group, or just email them out to the group if you would please. But
yeah,
I think that there's an idea that I talked about a while ago. It's called the scope of a relationship from a natural language. I mean, scope of transitivity for a natural language relationship, given the semantics of natural language. And once I get done with next month's read ahead, then I was going to hopefully work on that a little bit, but I might put a few things in this upcoming technical report. But it was the idea of having bounded concepts. Even though things might be transitive, there's at some point where our natural language concept about the object doesn't allow that to be transitive anymore. It's like, a thumb is a part of a person is part of an orchestra is part of a city is part of a state is part of a nation. Well, a thumb is not part of a nation in many senses, right? So where do you draw and how do you draw those boundaries so that it makes natural language sense? So that's kind of a containment for the semantic containment for the natural language. And I haven't really thought much more. Well, I've got a couple ideas, but I got to kind of give them more thought. So, but yeah, these are, and that translates directly to the modal logic and time, and work, how those things go together. So there's scope, the time, scope in time, and scope in configuration.
Right.
Well, we've got about 3 minutes left. Is there anything that anyone would like to add?
Well, I had a question about an email that you sent me. Sure. About, can you see it on the screen?
Sure.
You were talking about developing a new chart that has common structuring relationships. Could you say a little bit more about what you're trying to do?
Okay, so what we're doing, and this is going to be the basis or the outline kind of for the next technical report. But we're talking about, we're going to start with talking about types of definitions, because we're going to define relationships, and then we're going to talk about types of languages, because we're going to talk about relationships and represent relationships in the 3 isomorphic languages.
Yeah.
Then we go through and do a table, and so each natural language relationship, of course, is given a name tag, like is north of or equals or something like that. Then it is assigned a logical property group out of the AMEI, which is an attribute of that relationship. So we'll start defining that relationship using intension. So we'll say, this relationship has these attributes. Then we will, and some of the attributes, we will define those using extension. That we will exhaustively list all of the different combinations.
Yeah.
And then we'll, go ahead.
Yeah, that's what I thought you meant. I'm distrustful of starting from Warfield's list of relationships, because not many of them directly pertain to languages that we want to use ISM to model. I mean,
well, you know,
during his time, there weren't that many modeling languages out there. Now there's modeling languages and ontologies, and they have relationships that they define in them, and they don't always do a very good job of it. So for example, UML and aggregation. Aggregation is not that well defined in UML, but it's the best they got. And we should be trying to develop ways to use ISM with existing languages rather than Warfield, who developed it without trying to plug into existing languages. You know what I mean?
I agree with you wholeheartely. And so in going through that table and going through that list, I circled a number of those relationships that really I didn't really see how they could work.
Yeah.
And so I'm not taking all of those relationships out of there. And what I'm doing is the ones that I don't take out of there, then, you know, we'll have comments about why, right?
Yeah.
And this kind of discussion that you're talking about. If you're interested in ontologies and moving directly into a executable format for this type of work, I'm also interested in doing that. I'm looking at, this is talking a little bit ahead, you know, a few months down the road, but I've found a SQLite based type of semantic web ontology that's open source, freely available. I think it's maintained, was put out by the European Union. They have a number of these tools that are very good.
Yeah.
A year or two old, but you take RDF or any one of the other types of operational ontology languages, and then use that. So you know, it's lots of different ways to go, and that's kind of.
I mean, it is.
We're hoping.
I mean, one of the profound implications of this step that we're taking is that, you know, the most common, at least to my familiarity, the most common relationship modeled with ISM is influence. And if you look at all the languages out there, all the ontologies, I've not seen a single one that has an influence relationship in it.
Yeah, so hopefully after we start doing these definitions and the multiple languages, maybe we'll start getting some insight into why that might be.
Yeah. Okay, thank you.
Anyway, yeah, you're welcome. It's great having the meeting today, and I'll get the draft report out the next week or so people have some time to read it before the September meeting, which will be September, let's see.
September 2nd.
September 2nd at 9 o'clock will be the next one, guys. Thanks for being here. Bye-bye.